Good morning. Can everybody hear me? I hope you can. Welcome to the UKSTT Mini Masterclass webinar on traditional pipe reinstatement processes. My name is Roger Wahl. I work for Tracto-Technik UK Limited. This webinar is the first of a set of three webinars. On this webinar, we will provide you a little bit with more high-level information today. Please make sure that you use the questions tab to answer any questions which we will attempt to answer at the end of this session. So, first of all, I said to you earlier that I work for Tracto-Technik UK, that you might know better as TT UK, or we're also known as the GRUNDOBURST guys. So you'll ask yourself why I'm showing you this slide with this name Tracto. Basically, we are as Tracto in a global process of rebranding, and we will be known as Tracto from now on. It is more recognizable. It also rolls off the tongue much easier, especially in English, where Tracto-Technik is a bit of a mouthful, really. And of course, it allowed our marketeers to create a new, powerful image, which marketeers like doing. So today, the agenda is a short introduction to Tracto, our products, and our applications. I then want to talk about the drivers behind our processes. Before I want to touch on planning for the right process, and then to the core of the presentation, the product and process overview of our pipe reinstatement techniques. And last but not least, I wanted to introduce you to a possible link between some technologies and talk a little bit about KEYHOLE.
Can I start with your ear things? I don't know.
So a little bit about Tracto-Technik. We are a family-owned business based in Germany. We have got sister companies all around the US, the UK, Australia, France, Switzerland, and Morocco, all around the globe, I meant to say. Apologies. The company was established in 1962, and we currently have around about 600 employees worldwide. And last year, we achieved a turnover of just under 120 million euros. And our main focus is really trenchless technologies and trenchless technologies only. We specialize in providing solutions for trenchless installation and rehabilitation of underground infrastructure. You probably know us best for our soil displacement hammer, the GRUNDOBURST or the MANHOLE. But an important and growing part of our business is horizontal directional drilling equipment, where we do pit-launched machines from 4 to 6 tons, and then surface-launched HDD rigs from up to 28 tons. And our sister company, Prime Drilling, makes HDD equipment up to 600 tons in capacity. We also make pipe ramming equipment, pipe crackers, bursters, which is the subject of the presentation today, and we do a small auger boring machine. But we have a multitude of other products in our range, all centered around trenchless solutions. So why trenchless? Is it only about Less excavation? Well, that is certainly a main part. And our friend Todd Grafenau, the Vice President of Murphy's Pipelines in the US, went on the record in the Trenchless Technology magazine on the 14th of November and 14th of September 2020, and did this little graph to illustrate one of the major advantages of trenchless technologies, which is, less excavation. And in this particular example, he showed how the amount of spoil that has to be removed from a site can be reduced from just over 18 dump trucks to just under 1 through the use of pipe bursting. So yes, reducing excavation is certainly one driver to reduce cost. And in this slide, you see a lot of less, fewers, and reduced. So less reinstatement, less customer property reinstatement, garden reinstatement, less barrier management, less excavated spoil to remove, fewer vehicle movements, especially important in a city environments, reduced third-party liabilities, reduced labor and materials. And we really don't want to see any of these scenes here with badly repaired sidewalks, new road surfaces that are being cut open, sometimes cut open really badly, as we can see in the picture on the far left upper corner here, and big traffic disruptions through loads of barriers. But cost is really only one driver. There's a multitude of other drivers for us. For example, we want to improve connection efficiency, drive customer satisfaction, live up to our social obligations in our everyday work, look after the environment, and last but not least, health and safety. So trenchless techniques are reducing the CO2 footprint. They help reduce fine dust emissions, and we minimize the total time on site from start to finish. And we're ensuring that there is improved access. And I draw your attention to this picture with the elderly lady who came out on this site and asked how she was supposed to quickly get out of her front drive, just in case her frail husband needed to be seen by a doctor. So these all of these factors are the principal drivers that are common to all of us in the trenchless world. And I'm glad to see that on the UK STT landing page for pipe renovation, our little 400G has made it onto the page, our pipe burster. But I have to say it is under the headline pipe replacement, and we do so much more than pipe replacement. But yes, all the technologies that are mentioned on this page, on this very useful page, they all have their justification, of course. They all have their can-dos and their can't-dos. And when I talk about can't-dos, our techniques certainly have some of them. You want to watch us try to reinstate a square chamber in a sewer system, or indeed push a burster lead rod down a 45-degree bend. That shows you the demonstrations very vividly. So we all have our various unique process propositions, and to be able to choose the right technique for the right job, planning becomes paramount. It's all about choosing the right technique for the right job. And yes, I guess you are familiar with the principle of the 5 Ps, which stands for perfect planning prevents poor performance. So the start of the planning process is you ask yourself the question, what do I actually want to achieve in the short term and in the long term? Is my job about reducing leakage or seepage, and not only from the pipe out, but also from the outside into the pipe maybe? Do I need to improve the hydraulic performance, and is improving friction factors going to be sufficient to achieve the new performance parameters that I need to get, or do I need to increase the physical capacity, i.e. the diameter of the pipe that I want to reinstate? Do I need to reestablish certain static parameters? Or is it just a case of realignment? Maybe I've got a bit of a rise and slump in a gravity sewer that I need to sort out. Sure, we can come up with more points here that I need to consider, but for now, I think this is just demonstrating the point. Then, of course, we need to go into a more detailed checklist about my job. Do I know what hose pipe I've got? Have I got all the diameters, outside diameters, inside diameters, the profile, the material of the hose pipe? Do I know, or have I got specified the proposed new pipe material? Do I know the dimensions that I need to achieve? How about the position and the cause of the job that I'm looking to do? Have I got bends? Do I know where all the branches are? Are there lateral connections? Is my job in a walkway, in a road, or just by the side of a road, or indeed through the middle of a field? Do I know the exact depth of the existing pipe? Any adjacent infrastructure, surrounding ground conditions? Do I know what material the pipe was bedded in the first place? What are the wider soil conditions around? Do I know where the water table is? Will that affect me? How about my location, access to my site, the ability to lay out the pipe that I want to install? Have I got any manholes in the way? Again, what is the reason for my replacement? Have I been able to establish whether there had been previous repairs or previous attempts of rehabilitation? It would be best if it would have been possible to inspect the pipe. Have I been able to do CCTV? And last but not least, have I got, or am I going to be able to get all the permits that I need to do the job? And once we've answered all of these questions, we can then select the right solution for the job that we want to attempt, for the results that we want to get. And we then sincerely hope that the selection falls onto one of what we call our traditional pipe reinstatement techniques. And the techniques that we offer from Tracto actually give you quite a spectrum. You can install size for size, line replacement, so pipes with the same diameter, but you can also upsize. You can install a larger diameter, but you can also do traditional, let's call them slip lining techniques, and install smaller diameters. Without further ado, I want to start with the first technique that I wanted to introduce to you, which is the static pipe bursting. So let's watch a little video here. Very simply, we push a set of rods through the pipe that we want to reinstate, fix a bursting head, and then attach to that the pipe that we want to bring into the ground, in this case a size for size blue PE water pipe, and very quickly the job is done and our little man in the machine disappear. From Tracto, we offer a wide range of machines, and the nomenclature gives you an idea of the kilonewtons that these machines can generate in pulling force. So we've got from 40 tons to 250 tons. The smallest machine that we do can operate out of a 1 meter diameter manhole. Obviously, the capacity of the machine increases. Well, the size of the machine increases with the capacity. That dictates the size of the starting pit, and the size of the receiving pit may depend on the material that you choose, or it might be dictated by the material that you need to install. And when it comes to the pipe materials that we can install with static pipe bursting, well, basically, we think that just about any material that's commonly found in the ground can be replaced by means of static pipe bursting, whether it's stoneware, concrete, reinforced concrete, cast iron, ductile iron, asbestos cement, pitch fiber cement, PE, PP, PVC, PA, glass fiber reinforced plastic, steel, or indeed even pipes that have previously been relined. The choice of materials to bring in is a little shorter, but we can install PE, and they're not only long continuous coils, but also short pipes. PP, PVC, glass fiber reinforced plastics, ductile iron pipes, steel pipes, again the PA12, stoneware, and concrete. So there's a wide variety of pipes, and again, the length of the pipe doesn't matter. We can even install traditional socket and spigot joint pipes. That is a challenge, but not a problem. The success of the operation starts with the selection of the right bursting head, and we offer a wide variety of bursting heads. Here just a few examples, and I'll give you the example of the this cutter roller blade here, which is commonly used to cut open steel or ductile iron pipes, but it's also part of the bursting head string head assembly when, for example, bursting cast iron mains, where we know that there's already a number of steel or iron repair clamps fitted. Now, at this point, I must tell you that the first picture that you see here has been taken in the US, and our cousins in the US have got a slightly different approach to health and safety. So my apologies for not spotting that earlier and selecting a picture taken here in the UK. But it is still a useful illustration that this contractor is thinking about the fact that he is pulling in a pipe using brute force, and so he is making sure that as part of his process he is using a sufficiently good and strong front abutment. So the shoring of the machine is also another key part of the success. Second picture here shows the machine in operation, showing the ladder rods, which are very, very easy to use and are free of wear because of a complete lack of threads on them, which also gives them quite a bit of directional tolerance. So it actually allows for a certain amount of bend, but more on these details in our follow-up seminar in 2 weeks' time. So As mentioned previously, static pipe bursting can install a wide range of diameters, smaller pipes into existing pipes. Most commonly, we just replace equal dimensions, but upsizing is possible. We can hear from Tracto UK, we can always advise you when it comes to upsizing. But really, if you want to go above doubling the diameter of your existing pipe, we would always include our global product specialists from TT Germany to help you with these then experimental jobs. So again, our offer to you is speak to us if you are considering this technique. The second technique I wanted to introduce today is the so-called dynamic pipe bursting. Dynamic pipe bursting has been around for a long, long time. In fact, to the best of my knowledge, it was pioneered in the UK, but has somewhat fallen out of favor. It works pretty simply by bringing in a winch cable into the through the asset that you want to replace, and then attaching to that a pneumatic hammer with a bursting head, and attached to that is the new asset that you want to bring in. The machine, the process is quite fast and really quite inexpensive, but it has got a number of limitations. First and foremost, with it being pneumatic, it is not used for the installation of, for example, freshwater pipes, because the air will leave a small oil residue in the pipe. So it is commonly only used in sewer or culvert reinstatement. You can also only do brittle material with it. Because it works pneumatically, it works a bit like a mole. In fact, it is in the principle much the same as a mole. You cannot do ductile materials, you cannot do steel, and it requires a constant tension winch. Now, there's a lot of cable winches in the UK. There is not very many constant tension winches in the UK. So constant tension is a firm requirement here, and it cannot work under the water table. However, on the upside, you can achieve amazing distances. Our colleagues in the US do a lot of pipe cracking, and they commonly work on distances between 300 and 500 meters. But we have heard of successful completions of pipe bursts over a distance of 1500 up to 1500 meters. Really, you are limited by the amount of winch rope that you've got on the machine. We offer a range of different crackers through TT with the ability to install from 225 millimeter pipes to up to 560 millimeter pipes. So this is quite a range, and I hope you'll agree that this covers quite a few or opens quite a few possibilities for sewers and culvert reinstatements. You can even do smaller diameters, and that we achieve with our small Grundomats with the fixed head versions. So if you want to do work on, for example, private dwellings, again, speak to us and we may find a solution. But as I said earlier, you are limited when it comes to the materials that can be burst through this cracking process. Concrete, reinforced concrete, stoneware, cast iron, PVC, asbestos cement, or pitch fiber cement. And with regards to the new materials that can be installed, again, we can install PE, PP, PVC, steel, or PA, and you have the ability to not only install continuous coils, but also short pipes. One of the advantages why dynamic pipe bursting is still quite commonly used also on the continent is because you can burst towards very, very small receiving pits. And here the pictures show a burst that starts in a conventional pit, but then ends in a manhole. So, where size is an issue, cracking can be a viable alternative. Many of your jobs these days require the accurate recording, measurement and recording of the tensile forces on the actual pipe during installation, and you increasingly have to provide a log of the actual forces during the installation process to get sign-off from the asset owner. And here we've got a solution where we can install a logging device between the bursting head and the actual pipe to give you the actual and accurate readings that you can then extract and submit to your end customer, which is something that you don't really need for the next process that I wanted to introduce you to, which is our pipe reduction method, which really is our variant of swage lining. Now, what we do here, what we offer here, hopefully sets us apart from the rest of the pack, is the fact that we work with you even in the project planning phase to ensure that the pipe that you want to install is suitable and will give you a successful installation. We do this by finite element analysis, FEA, where we calculate and then simulate the forces that the pipe will see during the passage through the reduction die. And again, the process allows us to install pipes up to a length of 1,500 meters with outer diameters between 200 and 1,200 millimeters, and SDR ratings between SDR 11 and SDR 26. You can pull the pipe through the pipe reduction die by means of static pipe burster, or again with a constant tension winch. And then last but not least, I wanted to quickly talk about a process that you might say is not really a pipe renovation process, pipe ramming. And we would agree that pipe ramming is not really a renovation technique, but it is still worth mentioning because we can ram, for example, over existing pipes, or we can ram a new pipe into an existing passage, or indeed we can quite simply ram a new pipe in parallel with an existing pipe. And because pipe ramming has got such a minimal soil displacement, we require minimum top coverage and can minimize the distance between existing neighboring utilities. So that's the reason for mentioning the the pipe ramming at this point. So these are the 4 techniques that I wanted to mention today. As I said, we will be going into much greater detail in our next 2 presentations. But before we finish, I quickly wanted to take you back to this little illustration where Todd had shown the pipe bursting excavations here to install an 8-inch water main, starting with a 12x4-inch starting pit, ending in the same size receiving pit. But then he drew in 4 3x3 square pits. Now, presumably, I am guessing here that was to get access to reconnect some house connections, some service pipes following the pipe burst. But the question is, why do we need to go square? Why not go round? Now, some of you may have seen our Tracto keyhole technology, where we cut a round hole into a surface, take out the core, and then gain access to the acid underground. This was developed specifically for the gas industry, together with SGN in the ICORP project. But we believe that this technology is exceedingly transferable, and we were really pleased to actually carry out a job just recently where we worked in Suffolk in the UK, and a new water main had been put in, and we were asked to trial the keyhole technology, whether that would give benefits in the reconnection of water service pipes. So in came our keyhole truck, and we did the coring. We then brought in a little VACX air vac to excavate down to the newly installed mains pipe. This service pipe was actually installed using a Grundomat from the meter box into the keyhole, and then using our long-handled tools that were, as I said, developed for yellow pipes, but in reality the long-handled tools don't really care what color the pipe is. We did the complete process of reconnecting the service pipe, welding a new top tee to the newly inserted mains, and after a very short time indeed, the water was flowing again for the customer. So this brings me to the end of my presentation, and I would like to say thank you very much for giving me the opportunity to talk about these, what I like to call traditional pipe reinstatement processes. But I think I speak for the whole of the trenchless industry, regardless what our techniques are, when I say that the future of infrastructure renewal is trenchless. And if I could just now finish by inviting you to the follow-on presentation that we're going to have on the 29th of April again at 11 a.m. on static and dynamic pipe bursting, where we would like to go into much more detail than we've done today on these 2 processes. And then on the 11th of May at 11 a.m., we would also like to invite you for a presentation on pipe ramming. And that was me. Thanks for your Thanks for attending this webinar, and we will now attempt to answer any questions that we have. And I would like to introduce my colleague Roger Atherton, who is infinitely more knowledgeable on this technology than I will ever be. And Roger and I will try to answer any question that you have posed. Hello, Roger.
Good morning, everyone. Roger Atherton speaking. Please go ahead with your questions, and Roger and I will endeavour to try and help you.
I think Alice is going to assist us by reading out the questions that have been posed.
Okay.
Hello. So currently we just have questions that are asking regarding the presentation and whether it will be available after the presentation. So yes, the recording will be available on the UK STT YouTube channel, which will be sent out to everybody after the event's taken place within the next couple of days. Is there anybody that has any other questions at all? We haven't got any currently, so just check if there is anybody that has any questions at all for either of the Rogers at this point.
There must be somebody. I've not come on this panel. I've not come on this panel for no reason.
Do feel free to pose any questions now, or indeed contact us afterwards, maybe by email.
Okay, so we've got a couple coming in now. So
okay.
The first one is from Simon Goodyear, and the question is, do you sell the long-handled tools, and if so, a product brochure?
I can answer this one. Yes, the long-handled tools are now commercially available. The ICOR project has been concluded, and we have got a brochure which we'll be more than happy to provide you with.
And I am just waiting. Tom Sangster's just putting a question together at the moment, so I'm just waiting for him to send the press button.
Okay.
We've had one from Steve Crossman. Is the keyhole machine single size evacuation only?
I hope I understand the question correctly. Does it relate to the single size with regards to the size of the keyhole, the biscuit that we take out? That is currently 600 or 650 millimeters with our standard corer, but we also offer a larger coring machine where we can cut holes between 1 meter and 1 meter 50. We don't do smaller corers, and the minimum size of coring drum that you can install to our corer is 600 millimeters. I hope I understood the question correct.
Okay, so from Tom Sangster, you mentioned rectifying sags in, sorry, bear with me. You mentioned rectifying sags in pipes with pipe bursting. Does pipe bursting simply follow the existing lines, including any sags, or can it rectify the sag to the original gradient and level? If so, how?
We cannot work magic. Significant sags we cannot rectify with either the static or the dynamic pipe bursting, but if there's little corrections that need to be done, we can sometimes just simply by for example applying a little bit of a concrete bed in the sag, correct the sagging. But no, if it's more significant sags, then we have to think about other techniques.
We've had a question from Darren Dickinson. How automated is the coring technology compared to, say, SGN, ULCs, RRES which seems would complement your technology?
Well, the coring itself, well, to be honest, it is all rather manual. The coring machine, the latest iteration that we've developed together with SGN is remotely controlled, but it is a very, very manual process. There is no level of automation in there. However, as I said, often the process was designed to with SGN because they slipline existing cast iron pipes. We then expose the PE pipe that has been installed, and the task was to then reconnect the existing service pipe, or indeed, if that was an older material, drill a new service pipe towards the property. So there is very little automation in it.
Another question from Sabam Shiralasta. Can we use these techniques if the pipes are heavily blocked or already collapsed?
I can answer that one, Roger. I think where you have pipes that are heavily corroded or with heavy crustation from a water pipe, for example, if it's deemed that it has to be renewed, then there has to be some form of scrape and clean process first to enable us to push the quick lock rods through, in our case, first, so we can go ahead with the pipe burst process. But essentially, you have to have a clear opening or a clear existing hose pipe, so we can then carry out and conduct the pipe burst operation. Where you've got small holes existing within a hose pipe, provided we can get the rods through, then yes, we can carry on and do the actual pipe burst replacement.
I think the last one was the key. I think with basically most of our techniques, you've got to be able to get a rod through. If that is not given, then you may have to resort to conventional earth moving.
Sometimes it has been known where we've got partial collapse pipes, we can perhaps use something like a Cobra fiberglass reel to push through the small openings where they do exist first. Then we can attach that Cobra reel to the lead rod via an attachment to help bring back through the quick lock rods to bring it through the existing hose pipe. But as I say, once we can get the rods through the existing pipe by whatever means, then we can continue and do the pipe burst itself.
Okay, thanks, another question from Jimmy Foshi. What is the deepest the keyhole will core?
So this relates to the depth of the road surface. The deepest that we core with our 600 or 650 millimeter coring unit is 600 millimeters, and that is driven by some of the surface sizes that we see, especially around London. It can be up to 550 millimeters in depth, and also you know, a combination of tarmac and reinforced concrete. So 600 millimeter cores is the deepest that we can cut. When it comes to the keyhole depth, generally, because it was designed for the gas industry, generally we then cut a keyhole down or suction excavated down to around about 1.2 meters to fully expose the gas main that we are expecting at around about a meter in depth.
Another question that we've got in from Farhed Mohammed. Does static pipe bursting needs 2 pits? Instead, we could make pit and the other end for burst head can be operated through the manholes.
Well, we've got the 400S that can, where the manhole, the 1 meter manhole, is the starting pit. The shape of the the end pit is very much dictated by the pipe material that we want to put in. When it comes to bursting into a manhole, we've seen that the dynamic pipe bursting is often a viable option. The answer is a clear, it depends. It depends on the product parameters. It depends on the materials that you want to install, and we are always there to discuss these parameters and suggest what we think is an appropriate technique. And if we can't do it, then we're not shy to say that we can't do it.
If I could just add to that, Roger, to the person that asked the question, generally speaking, we can pipe burst from pit to pit, manhole to manhole, manhole to pit, pit to manhole, in any combination, really, as Roger's quite rightly pointed out. Because when we are using dynamic pipe bursting, for example, our machines have the capability to be able to be reversed back through the product pipe that you've installed. So if we have to arrive into a manhole, then that machine would arrive into the manhole. We would witness the head arriving. We would then simply select reverse back at the start pit where the machine's being operated from, switch the machine to reverse mode. That would drop the expander into the manhole where we've arrived, but the machine would reverse itself right the way back through the existing pipe that we've installed, so we could retrieve the machine back from where we started. So there isn't much that we cannot achieve, and if we have to, as Roger said, if we have to tweak here and there, obviously we do so. But yeah, the only concerns that I would have whenever we're bursting from an existing manhole is what state or how strong is that existing manhole, because while we can produce a 40-ton machine to burst from a manhole, sometimes the manhole is not strong enough to withstand them forces where we are reacting against. So sometimes it's necessary to work perhaps either in front or behind the manhole rather than inside the manhole. But all these things are discussed when we look at individual projects. So I hope that's answered your question a bit further. Thanks, Alice.
We've got a couple more questions, so I'll just get round to those. There's Andy Lung, who has asked, if the host pipe is encased in concrete thrust block, how to evaluate the feasibility of using the pipe bursting technique for the job?
Very valid question.
Thanks for the question, Alice. Thanks for the question to ask that. Yes, we've been involved with many projects where the existing host pipe is encased in concrete, and we've successfully still carried out the pipe burst operation. It really all depends on the thickness of the existing concrete surround, the type of surround that it's encased with, and also you know, the hardness of that existing concrete, for example. Sometimes we have to adapt and design burst heads that are more aggressive, shall I say, than our conventional off-the-shelf pipe burst heads, where we know it's just a normal fracturable pipe. So again, we have to look at each and every individual pipe burst project, look at individual runs where we've got these concrete surrounds, and determine and calculate whether we believe that our pipe burst machines can successfully burst these pipes. We would look at the calculation formulas that we can produce from the impact energies from our machine. So we have a pretty good idea before we say yes whether we can actually physically burst a concrete surround. But yes, in the past, and I've personally been involved with projects overseas and in the Middle East, for example, where we've burst existing concrete pipes where we've had up to 12 inches in concrete surround. So yes, the answer is possible, but they all have to be looked at individually. Thanks for the question. Thanks, Alice.
Another question from Trevor Cox. In certain countries around the world, i.e. Middle East, open cut for road crossings is illegal. I see many open cut operations down here in Sussex that would be perfect for Grundomat or Grundodrill application. Is there any sign of a similar legislation in the UK for road crossings?
We are keeping our fingers crossed, but unfortunately, I don't think I can answer that question. Let's work together towards that, and I think the UKSCT is probably the right forum to do that, to work towards that. I see this myself many a times. Just recently, near my home in Staffordshire, I saw a company that's even involved in trenchless techniques, cutting open a perfectly good road, closing that road for several days, just to install what looked like a little 4-inch pipe. So I stopped there and asked why they didn't consider trenchless techniques, and I think it's fair to say that I got blank stares.
Trevor, many thanks for your question. Good that you're on the webinar. Trevor, we need all the help we can get to try and push trenchless with the aid of people like the UKSTT, and we keep working at all these challenges that are put up against us, and you know, we need the help of these webinars and the help of governments to get these things more driven. So yeah, good question, Trevor, and thanks again, and catch up with you soon. Thanks, Alice.
Okay, so there's 2 more questions, so I'll just get through those. Do you think there is still a healthy market for bursting in the UK? And that's from Darren Dickinson.
That is a very valid question. At the moment, I would say the answer to that is no. Which is one of the reasons why we've embarked on this set of webinars, because we thought very often I hear comments like, we can't burst, it just takes too long, we can't take them off the water for days, and we think to ourselves, well, it doesn't need to take that amount of time. Or we are being told that it's simply too expensive, and but you see, sometimes there is no other way to achieve what you want to achieve, and our quest here is really to just remind a lot of people of the capabilities of the process, and to invite them to talk to us, so that if we can plan a job properly and we can help in the planning, it can be we want to show that it can be a very fast and very efficient technique that will install a new asset that is, you know, I mean, that is has already proven to last for a long time, that will reach its design life expectancy, and has proven that over the last couple of decades. It's the best way to install that new asset, and unfortunately there is such a big emphasis on time of service these days. And we would like to try and shift that emphasis towards total time of completing a job, because it's not only the time of service that disrupts customers' lives, it is also the time that they can't easily get down the road that they live in, that they can't easily get onto their drive, or indeed off their drive when they want to, that they can't push their pram past the many barriers that are standing around, and they can't find a car park in front of their own house, because there's a huge, big excavation there. So it would be nice if we could shift the emphasis on total time of completing a job, not only time of service.
If I could add to that, Roger, as well. Obviously, being an employee here for some number of years now, and having spent most of my career in the trench, so to speak, I know that there's so much more opportunity for pipe bursting here in this country, but worldwide. You know, we see all our major cities around the world crumbling under the old aged infrastructure now. We, all of us, got to try and push trenches so much more. I personally, from my personal viewpoint, we don't use pipe bursting enough. Yes, we see a lot of new technologies coming into into play now with pipe rehabilitation, and I've got nothing against them at all. You know, we all need to contribute to help rehabilitate and renew our pipes, but I do believe that we've lost the generation, my generation, that have now since retired, where pipe bursting was being carried out on a daily basis. We've got to get back to doing a lot more pipe bursting where we can arrange it, we can do it simply, quickly, efficiently. I just think that we need to start to re-educate the new generation of engineers that are coming into our industries now, and bring them back up to speed to what we were doing back in the 80s and 90s, because we were doing it then, and we were doing hundreds of meters a day in the gas industry, in the water industry. My big question is, why are we not doing it now? You know, it's okay to temporary sometimes prolong a pipe, but let's get back to pipe bursting where we can create a new asset for the next 80 to 100 years. We can do it, and I just think, and I blame ourselves as a group of companies that we've not perhaps been shouting from the rooftops, hence the reason why I'm repeating what Roger's just said. But we do need to be pipe bursting again. It's not difficult, it's not rocket science, but by God, it gives a fantastic end result. So thanks for a great question. The former questionnaire, Trevor Cox, would understand where I'm coming from as a person also that knows that pipe bursting has a big future for trenchless technologies.
Thanks, Alice. Hello?
Sorry. Can everybody hear us again?
Yes, it's come back. I'm not sure what happened there, so apologies for that slight interruption. We have one final question, which is from A. Ghani Mohammed, and it is: some public roads are full with other utilities. Is your bursting technique impacts with damage these other utilities? I think he's asking, will it damage these other utilities?
There is a potential, absolutely. That's why planning is so important. That's why we need to know exactly what is in the ground and where. And it always depends. I mean, if you slipline a pipe, then obviously you haven't got a problem. If you replace diameter for diameter, size for size, then the problem may be minimal. But if you upsize, then you may need to take a very careful look at the distances to neighboring utilities and also to the depth of the existing pipe, because what we don't want to do is damage the surface through the operation that we do trenchlessly. It is really important that we have all the details in the planning process to avoid unwanted catastrophes.
Yeah, the minimum distance adjacent to adjacent pipes really depends on the soil conditions, the coherence and the compressibility in the first place, but and the type of adjacent pipes and the structures. And in cohesive grounds, for example, the clear distance to parallel pipes should be at least, we've learned from our experience, 5 times the upsize coefficient, but never less than around 400 or 40 centimeters, 400 millimeters, which is around 16 inches. But again, I can touch more upon this when we do our technical presentations.
In 2 weeks' time, we will have a lot more information on these parameters. They are really, really important for the success of the operation.
But a good question, and thanks for the question.
Absolutely.
Thanks, Alice.
So that's all of the questions answered now. So thank you both Rogers for your time today. The presentation was fantastic. I think everyone would agree. And for anybody who would like to be on the Thursday the 29th of April webinar, you will be sent an email with the link to the registration for that later on today or tomorrow, so that you can sign up to that one, and also the pipe ramming presentation, which will be on Thursday the 13th of May at 11 AM also.
Good.
Okay, thank you very much for attending, and thanks for your interest.
Thank you, Alice. Thank you, Lynn, and thank for all the attendees, and thanks for all the great questions. Look forward to
the UKSTT for putting this on. Thanks a lot for the opportunity. Okay.
Thank you. Thank you.
Thanks. Bye.